You're tuned in to the Data Masters podcast. In each episode, we dissect the complexities of data management and discuss the data strategies that fuel innovation, growth, and efficiency. We speak with industry leaders who share how their modern approaches to data management help their organizations succeed. Let's dive straight into today's episode with Anthony Dayton.
Welcome to Data Masters. Today we have a great guest joining us, Rouzbeh Gerami, Senior Vice President of Data Science at Nielsen. Rouzbeh brings a wealth of experience from industry leaders like Z-Axis, part of Group M, TAPAD, and Yumi, making him a true powerhouse in data science and analytics. With a PhD in physics from UCLA and extensive experience in areas such as quantitative finance and mathematical modeling, Rouzbeh has led transformative projects that shape the way we measure media across digital and TV platforms. At Nielsen, he's currently at the helm of groundbreaking methodologies, including Nielsen One Ads and Nielsen One Content, empowering clients such as Google, Meta, Amazon, and Disney to engage audiences with precision. Today, we'll explore Rouzbeh's journey from academia to industry and the challenges of cross-platform measurement and his vision for the future of data science in the media landscape. Rouzbeh, welcome to Data Masters.
Thank you, Anthony. Happy to be with you.
So maybe we could start a little bit with your background. And it's interesting, at Tamer, we have a whole bunch of people who have physics as their academic degree, physics PhDs, as you do. What is it about physics and data science that creates this strong, pipeline, pun intended, of people who come from physics into data science?
That's a very good question. So thank you. First of all, thank you for having me. Glad to be part of this conversation. That's a very good question. So yesterday, the newest Nobel Prize winners in physics were announced. And many people were surprised that Geoffrey Hinton, who is not a physicist and one of the founders or founding fathers of the whole AI revolution through his investigations of neural networks, backpropagation algorithms, and things like that, was awarded a Nobel Prize in physics. And you would think, okay, he's a computer scientist. But so the question you're asking is, why is it physicists go into other directions all the time? As you see, it's not a one way. You see, we can bring in computer scientists and call them physicists and give them Nobel Prizes as well. But to answer your question, physicists tend to have, practice or forced to gain a few skills that are useful. One is try to solve problems that are not very well structured. Two, perhaps know quite a bit of math. Three, know quite a bit of programming. And four, sort of being used to, working hard at something that seems unsolvable at first. The last one is not a physics thing. It's just, many of the sciences would force people to really be good with uncertainty, trying to simplify things, try to model or create simple model that will capture the essence of the phenomenon and try to understand something on it and not be lost in the complexity of it. All these things are attributes that physicists are forced to be good at, along with many other fields, but physics in particular. Having these skills then allows people to explore other fields that are not necessarily there in their formal education or within their formal field of education. I've had a similar experience. I mean, I worked in condensed matter physics, and if you ask what it is, it has nothing to do with anything I've done afterwards. It's sort of a study of matter in its condensed form, either exotic matter like, let's say superconductors at room temperatures or potentially room temperatures and stuff like that. Or let's say biophysics, what are the properties of, let's say, proteins and cell membranes and things like that. From that, again, I, gained some skills along the way, which, after my PhD, I tried to apply in other fields. I did some work in mathematical finance, as you mentioned, and I have been in data science and AI field in the past 10 years. And I've sort of observed firsthand as much as it was visible to me, how much the field has changed, how much the industry that they try to employ data science and AI have changed, and have used AI and data science to the better. So it's a very fast-moving world. The industries change, tools that we use change, and it's a challenge for everybody to sort of try to be on top of it, try to make sense of everything, and try to take advantage of all the opportunities. So that's what we try to do at Nielsen these days.
So let me posit a slightly different answer, or maybe it's to agree with you in your answer about physics versus data science. I think when we think of physics, we think that there's some sort of objective reality out there that we're trying to describe mathematically. But the practical reality of physics, the day-to-day reality of physics, is it's really a measurement problem, that you're trying to observe a real phenomena, and you're using sampling and measurement to capture that real phenomena, which you could then hopefully describe mathematically, but you're really trying to observe some objective reality. Is that a fair summary?
That's a good point. Meaning, if you go back to what the definition of physics was, 500 years ago, there was no such thing. Everything was a branch of philosophy. But at some point, it was clear that there is an experimental field that needs to be, combination of mathematics, mathematical models, and observation that sort of sets it aside from traditional philosophy. So you have a point there. This is the way physics has, you could say, since the days of Newton, has evolved or has started. But once you have a set of tools and you have certain methodologies that you have worked on physical world, then nothing stops you from applying them on things that are not from physical world or not traditional physics. The many tools would be similar, many insights could be very similar, many approaches could be very similar. So having learned a certain set of tools and methodologies and principles then allows you to go out and apply them in other fields. Physicists think about issues in biology, in economics, in ecology, in many other fields, let alone, hard science fields that are very close to it, like chemistry. But it's been all very fruitful and useful because the approaches are, applicable in other fields. But you have a point that a sense of it is not physics, and we are not measuring or modeling physical world. But nonetheless, we have tools that are applied or applicable.
Right. So in that sense, that's what I was trying to sort of bring us to, which is that the work at Nielsen is in a way not dissimilar from the work as a physicist. But maybe before we get into the details of what you're doing at Nielsen, which I think is fascinating, it might be helpful to step way back for folks and just help explain what business Nielsen is in. And I bring it up partly because I think we have this intuitive understanding of who Nielsen is, the business, who's in Nielsen families. Maybe you have listeners on the call who even were Nielsen or are Nielsen families. So we have this idea of what Nielsen is, but I think that's probably out of date, and certainly out of date as it relates to the work that you're doing. And so maybe it's worth catching people up, so to speak, in terms of who is Nielsen? What business are you in? And
It's a very good question. Very good question. Thank you for asking that, Anthony. As you mentioned, we are a company that was founded 1923. We are 101 years old. Obviously, we are doing things or different things that we were doing 100 years ago, 50 years ago, or even 20 years ago. And this all goes back to your point that people have a traditional sense. 30 years ago, it was very obvious what we were doing. Today, or let's say 5 years ago, less so, and it goes with the change of a lot of big changes that I will talk about. But 30 years ago, so generally Nielsen has been in the business of audience measurement, figuring out the size and properties of big groups of people. One aspect of that is that big groups of people that consume media. So people who produce media do it for their content to be seen by mass audiences, and it's a very relevant question for them. What are the properties of this mass audience? So measurement of this mass audience is our business, and the core of that is measuring media audiences in media. So there are three different terms here that might need clarification. What is audience? We talked about it. It's just groups of people. What is media? That definition has changed and continues to change. And also the question is, what is measurement? Let's address with media first. 30 years ago, people watched TV mostly, and people watched 3 or however many few broadcast channels, maybe cable. It was straightforward. If you wanted to get your message across, you had a clear path. Let's say in terms of visual media, for example. That was very clear for people who created content, for people who wanted to do advertising. That world does not exist anymore. People watch TV less and less. People do more and more other forms of media consumption. It could be social media. It could be watching, let's say, YouTube and Netflix and other forms of streaming. The old model of watching a certain particular show at a particular time in the week has been completely replaced by watch anything, anytime. And also in the middle of watching something on Netflix, browse TikTok and post on Facebook. This seems nice and fun. At the same time, it's very challenging for people who want to know who they're talking to and where their message goes. And it has very practical implications in wide industries that goes beyond media. Now, talking about what measurement is, in the old world, measurement was a lot simpler in the sense that we have access to something called Nielsen panel. Nielsen panel is tens of thousands of households that partner with us and give us visibility into their media consumptions. That would have been enough to give full visibility with enough precision in most use cases. That particular traditional approach may not work in a world that I described that, contains YouTube, TikTok, and Netflix, and everything in between. And someone who wants to know where their message went, or where the content went, they have to figure out who saw it where and who saw it through many different channels. And let's not, double count. So old measurement is different from, or today's measurement is very different from what old measurement was. And we have this big problem to solve at Nielsen, that as the media industry is transforming, how we transform with it and stay ahead of it, and are able to answer very fundamental questions that people have in terms of who's exposed to what. I'd be happy to give more details as we discuss.
So I wanted to pull on this for a second, because I think you made this point that Nielsen's a 101-year-old company. It's a very different company today than it was certainly 101 years ago, even probably in the last 5 years, 10 years. It strikes me that, and I'm admitting to going a little bit off topic here related to the Data Masters podcast, but I think it's interesting because I think a lot of people listening to this podcast work at big companies, and big companies historically have had an incredibly difficult time innovating, keeping pace, changing the business they're in. And I think it'd be hard pressed to come up with an example of a company that's had a harder time or had a harder challenge, maybe would be the way to say it, than Nielsen. Because very much to your point, media consumption today looks radically different than it did even a year ago, let alone 10 years ago. And just as a slight context for the question, my first job internship was at Leo Burnett, looking at media placement for advertising. I will decline to say exactly how long ago it was, but suffice to say, we were buying paper copies of Nielsen data that we would use. So it may be a slightly unfair question, but we've talked before on this podcast about the innovator's dilemma and how to kind of transform and shift a business. What is it about Nielsen that allows the organization and maybe what your role in that has been to actually keep pace with this change and rethink the business, especially as it relates to media, audience and measurement, as you point out?
Thanks, Anthony. This is a very important question. This is what I certainly am tasked with thinking about. And I certainly do think about it quite a bit. As you mentioned, there are many different companies that had dominance that went away with changing times. We know so many examples. We are certainly mindful of it, but at the same time, we think we are staying ahead of it. We are still a very important player in audience measurement field, not only in the old traditional media of, let's say, linear TV, but also in the newer digital platform. And that's what my day-to-day job involves. And we have, as you mentioned at the very beginning, we work directly with biggest media companies in this new world, be it Google, YouTube, TikTok, Netflix, and all the other ones that are in between. The challenge is this: it's not so media consumption shift, and we, along with it, we have worked hard to stay relevant and measure things accordingly that would not have been measured or measurable with the old methodologies and old data sources. Measuring something like, who saw, a certain video on YouTube or a show on Netflix requires a certain additional data sources and certain methodological and algorithmic approaches that we have worked hard to create and innovate. And as a result, we are confident that they are leading us towards being able to accurately measure all these details and all these complexities. In addition to being able to innovate, being open to it, and being open to, challenge existing practices, there's another thing that's important for Nielsen, and that's the Nielsen panel that I mentioned. In the digital world, as media consumption moves to the digital world, there has been a movement towards protection of people's privacy in the digital world, which is long overdue. There's a lot of benefits to additional privacy protections for everybody who is online. And as I mentioned, long overdue. People were not thinking about it. Practices have been in place that should be changed with more privacy-safe practices. There is a side effect to it, and that is, in many cases, many smaller, let's say, publishers on the open web would have less access to good data, who's doing what on their platforms, and as a result would be less able to monetize their content. There would be a shift away from, let's say, smaller publishers on the web towards bigger publishers in walled gardens. Generally, the one result of this is less clarity in terms of generally what people do, how advertising is spent, what the effectiveness of it, and again, who's watching what. It becomes more and more difficult. It also makes it more important to have access to, you might call it, a high quality source of truth. That would be our direct observation of our, very privacy safe way of having access to direct observations that we need to make. If we need to measure something properly, we need to have proper truth data or ground truth in order to power machine learning algorithms or general, more innovative methods and power new methodologies. That's what sort of empowers us as a very important input data to, move with the times. So movement or the shifts in the world is not just that people are more on their devices versus watching linear TV, but also everything else regarding What type of data is available, and what should be available, what should not be available. Certain data should not be available, and fortunately, the world is moving that way. That, as I mentioned, creates challenges that we feel we are placed well in order to address in this new, more privacy protected world that we are moving towards.
So I want to come back to the privacy question in a moment. But I love this idea of ground truth, and it's something we think a little bit about as well at Tamer, acknowledging that Tamer's thinking more generally about the question of making high quality data across many different kinds of entities. But we too have found this reality, which is that if you have ground truth to map entities to, you're more likely to actually identify those entities correctly. And so having access to, taking an example like firmographic or company information, if we know that there's a real company out there, called, whatever, Nielsen, when we find Nielsen misspelled, we can match it to Nielsen spelled correctly. And we can say, oh, okay, this is, there happen to be at the same address. And so therefore we're very likely, the machine learning is relatively likely that this is in fact the right thing. Is that the sense in which you're talking about ground truth? And then I want to come back to the privacy question.
Yes, definitely, because this is a very data-rich world. People spend so much time and consume so much on their digital devices, and it creates massive amount of data that are accessible to their publishers, that are generating the content and stuff like that. As we work with publishers, let's say YouTube or Netflix, we have access to a certain form of very massive data sets on their own would not give us the right picture and would not be giving us the accurate answers that we want to know in terms of how many people within a certain age bucket were part of this audience, and who actually, or what percentage of the people who said they were above a certain age were not, and who was watching their content on their parents' device and this and that. None of this is really directly observable on the massive input data that publishers have. Correcting them or adjusting them or modifying them or really finding the truth requires models that have learned from ground truth and have learned to generalize to massive data sets. That's the promise of, or that's what machine learning models do. Show me examples. If you show me enough examples, I discover the underlying patterns. Now I'm able to tell you things about new cases for which you don't have a ground truth. Without that, you effectively won't be able to train good machine learning models in order to apply that massive data sets and at scale. And again, this data set becomes more and more valuable as other forms of data formerly available without people's full consent goes away, and rightly so. So this goes to the core challenge of discovering information from massive data sets, or massive data or massive data sets, without having some training set. Just massive raw data would, useful, but not useful for everything. Having good quality training data would open doors that, would solve a lot of problems otherwise unsolvable.
So this is in fact connected to the privacy question, which is what I wanted to come back to. So I'm glad this wasn't a complete diversion. And maybe to try to articulate this, your point is, if we can have high quality ground truth data that we can match against, this allows us to maybe relax the privacy constraints. We might give people more privacy, but then also provide, in your example or in this industry, your publishers better access to more accurate data about audience. And in that sense, again, I don't want to put words in your mouth, but I'll try, and then you tell me if I get it right. But this is like having your cake and eating it too, meaning give people a sense of privacy and give publishers high quality data about audience. Is that am I overreaching?
I mean, in our mission statement, we don't have help people with eating their cake and keeping it too, but we'll do our best. The thing is, the truth is, if you're a huge established company like Google or Facebook, you know a lot about your consumers and maybe too much. That cannot be said about a newspaper publisher in a small city that wants to know who's watching their content. It's very important for them to show advertisers how many of their viewers were in certain age that would be valuable for advertisers. They need to have that data. Previously, maybe they were able to, or 5 years ago, it was easier to access that information. That information becomes less and less available and more and more scarce. If we can help anybody, those would be the people that would be helped in the new world with existing information going away. That, as I mentioned, privacy protections are valuable, important, necessary, and long overdue. They will have side effects that we should be aware of and work towards fixing. And that's part, we can help there. We cannot solve that problem completely. Because, for example, let's think about advertising. A newspaper publisher in a small town would need to do several different things in order to stay in business. They need to attract advertising. They need to show the advertisers how effective it was, meaning show them my readers, ended up spending this much on certain advertiser websites. And you also need to know the demographic composition or other things regarding your audience. We are not in the business of, let's say, figuring out what people do with advertising or what they buy. We're in the business of telling people what was the demographic attributes and, whether a certain or what portions of their audiences were in particular audience segments and stuff like that. The questions of effectiveness of advertising remains challenging and would be difficult and may become more and more challenging. It's a truth that there would be a price and there's a side effect. The side effect would be, and the price would be paid with the likes of a smaller newspaper publisher in a small town. We should be aware of it. The society should know about it, and society should see and decide whether or not this is acceptable. Should we have processes in place to protect, small publisher like that, or we are okay with, the consequences and the shifts in the, many different marketplaces that will follow. As mentioned, that's way beyond our mission statement, and certainly way beyond, what I'm supposed to think about. But we should be mindful of it because I have some visibility into what's happening. And as a society, we should be mindful of it, that, there is certainly valuable, small open web publishers that would have, a challenging time to survive as a result of all these changes that are happening in the industry.
Sure. And I want to be careful not to delve into the societal implications because, as you point out, it's certainly beyond the scope of this podcast. But maybe I could draw an analogy and you tell me whether I'm misstating the case, which is in a business that's trying to measure the success of individual product lines, the tendency is to spend energy and focus on the big product lines, and the long tail of products are ignored. And there often is great opportunity in the long tail. And if let me posit this as a suggestion, and you tell me if you agree, that the strategies that you're employing around sampling and thinking about ground truth could be very helpful in any business thinking about how to measure the full distribution of any process that they're measuring. I used sales just because it's one that people intuitively understand, but it could be almost anything. Think HR, think product development, think machines on a factory floor, whatever. But thinking about using ground truth and sampling as a way to really understand the full distribution of data and also where those maybe hidden nuggets of opportunity exist. Does that
That does make sense. Yeah, definitely. This opens doors. If I were thinking about opening startups, maybe I would think about your suggestion seriously. At the same time, that ground truth data that I mentioned is not of infinite size. This may not cover everything. So the data, the ground truth data that we have access to has, you know, certain size that, we know about and would give us visibility into not everything. Again, if you're a small publisher with little traffic, we may not have that much access in our panel to your audience. So we alone may not be able to solve everything. Having said that, there are certainly opportunities. This is a data-rich world. With data, you have access to machine learning with algorithmic approaches to sort of make discoveries. Certain discoveries are easier than others, but nonetheless, machine learning is a tool to gain insight from massive data sets. The more ground truth, the better, but nonetheless, this doesn't fully close the data, and actually, as to your point, makes it more important for people to get creative and solve problems with new methodologies. Some of these problems have not been solved really with new methodologies. So there is opportunity.
There's big opportunity, absolutely.
But the problem has not been solved at the same time.
So I want to shift gears 180 degrees and bring us back to where we started, with your permission, um, and in a way close the loop a bit on where we started. You started your academic work as a physicist, even worked in that area for some time, and now you're dealing with data and measurement and truth, et cetera. At the risk of putting you on the spot, imagine that one of the listeners out there is themselves a young aspiring physicist, maybe even in a PhD program, um, and maybe has some concern or angst about working in physics directly. What advice would you give them as they think about what they want to do with their lives, and reflecting back on your own journey?
Thanks, Anthony. This is very important. As you mentioned, physics people generally have been thinking about these types of questions going back many decades. What can I do with my skills? And the emergence of data science, machine learning, and AI as a field has opened new doors, and physics, people with physics background are fully aware of it. And I know so many people with physics background that have done this, gone through the shift that I went through. The thing is, the hypothetical person that you mentioned should continue doing, let's assume someone in a graduate school working towards PhD. The PhDs would, in vast majority of cases, the graduate programs are training people that are supposed to be, full-time researchers, or go and continue the research that they're doing now in future. The truth is that only a small minority of people continue in the field of their thesis. So that's understood, that as you work on what you have to do to get your PhD, be aware of what other skills you need. That other skills could be programming, could be additional mathematical topics, could be additional, let's say, machine learning topics, could be any form of useful, skills that might help you in future, but you don't necessarily need a formal education on. There's added complexity to it. Like when I was in grad school, I knew that I need to learn, let's say, a programming language. If you ask me now, how much time should I spend on learning or mastering a programming language? What would a software engineer, or what would coding in general look like in 5 years or 10 years or 15 years? I don't have the answer to that. I don't know if many people do. And Anthony, if you do, please educate me as well. So that's complex. Nonetheless, those skills have to be kept refreshed. Like, for example, if I need to use coding assistant, AI-based coding assistant to generate good code, that's a skill to be learned. That's not the skill that I learned when I was learning programming. But the world is changing. Programming would mean different things, again, in 10 years than it does today. So the hypothetical would-be physicist should keep all that in mind. Be ready for a changing world, and also stay curious and continue learning. It would be very unlikely for anybody to learn one skill once and have a full career based on that. There was a time that if you went to the medical school or law school, you become a doctor or lawyer, and you would have a full career based on what you learned at school once. We are not in that field. Even doctors and lawyers have to be careful how the world around them is changing. So anything we learn that powers us through a portion of our career would get old. At some point, we should be mindful what we need to move forward and what we need to learn. So continuous learning would be very important. And a person with a physics background should be good at it. Anybody who comes into this field should be prepared to reevaluate, relearn, and do things very differently that they were doing before. So that skill also should be really very important to keep in mind.
So what I hear you saying is that the value in a physics degree in this hypothetical example is learning how to learn and how to be flexible and respond to a changing world, as opposed to learning the hard skill. And very much to your question and point around programming languages, I think you're probably correct that it used to be that learning the actual language, the programming language, was the valuable thing. Today, I would say that it's learning how to think programmatically. Generating the programming syntax is, to your point, is very much something that programming assistants, co-pilots can do. But the mode of thinking is something that is learned and it is valuable. So, very much in support of of what you say. Well, Rouzbeh, thank you so much for joining us on Data Masters. A great conversation, and hopefully there is a junior PhD physicist listening, and hopefully they change path and take advantage of this conversation.
Thank you to you, Anthony. Thank you for the time. Physics people would find their ways. I'm not really worried about them, but it's a changing world, and everybody should reevaluate what they're doing. Thank you again for the time, and appreciate it.
Pleasure.
Thanks for joining us for the latest episode of the Data Masters podcast. You'll find links in the show notes to any resources mentioned on today's show. And if you're enjoying our podcast, please subscribe so you never miss an episode.